wire 3 meters long and 3.15 millimeters diameter is extended by 0.9 millimeters when a tensile force of 200 newtons is applied to it. Calculate Young's modulus of elasticity for the material of wire, assuming that the elastic limit has not been exceeded. So today we are going to solve this question, and you are once again welcome to my channel. So let's move on with the solution. Okay, all right. So the question is, a wire 3 meters long and 3.15 millimeters diameter is extended by 0.9 millimeters when a tensile force of 200 newtons is applied to it. Calculate Young's modulus of elasticity for the material of wire, assuming that the elastic limit has not been exceeded. Okay, so please make sure you subscribe to the channel. Please make sure you subscribe to the channel, and don't forget to share the videos. All right, so let's move on with the solution. So Young's modulus of elasticity is defined as the ratio of the stress to the strain. Okay, so we first of all calculate for the stress. When we finish, we calculate for the strain. Then we can solve for the Young's modulus of elasticity. I hope you understand. Okay, so let's first solve for the stress. And by definition, stress is also what? The force over the cross-sectional area, or the area force over the area. That is the formula for stress. All right, so let's first calculate for the area of the wire, or the cross-sectional area of the wire, and we use the formula pi d square over 4. D is the diameter. Okay, so we have 3.142, which is pi, okay, multiplied by the diameter, which is 3.15 square, okay, diameter square, d square. So 3.15 square over 4. And when you divide, we are going to get what? 7.79 millimeters square. So the area of the wire is what? 7.79 millimeters square. Okay, so since from the question we have been given the force, which is 200 newtons, let's move on to calculate for the stress. Okay, and the stress is equal to what? The force over the area, force over the cross-sectional area, or the area. So we have 200 over 7.79 millimeters square. So 7.79 millimeters square is what? The cross-sectional area, and then 200 is the tensile force. Okay, 200 newtons, that is the tensile force. So when you divide 200 by 7.79 millimeter square, we are going to get what? 25.7 times 10 raised to the power negative 6 Newton per meter square. So the stress is equal to what? 25.7 times 10 raised to the power negative 6 Newton per meter square. Okay, so from the question, the original length of the wire is what? 3 meters, and the extension of the wire is also equal to what? 0.9 millimeters. So we can now calculate for the strain. Okay, strain is equal to the extension over the original length. Okay, and the extension is what? 0.9 times 10 raised to the power negative 3 over 3, which is the original length of the wire. Okay, 3 meters. So 0.9 times 10 raised to the power negative 3 over 3. So when you divide, we are going to get what? 0.0003. Okay, so the value for the strain is what? 0.0003. So now we have calculated for the stress, which is what? 25.7 times 10 raised to the power negative 6 Newton per meter square. And we now have the strain to be what? 0.003. So we can calculate for the Young modulus of elasticity now. Okay, so Young's modulus of elasticity E is equal to the stress over the strain. Stress over strain. And stress is what? 25.7 times 10 raised to the power negative 6 divided by the strain, which is what? 0.0003. So when you divide 25.7 times 10 raised to the power negative 6 by 0.003, we are going to get what? 85.67 kilonewton per meter square. Kilo is what? 10 raised to the power 3. So we have 85.67 times 10 raised to the power 3 Newton per meter square, or 85.67 kilonewton per meter square. Thank you so much for watching.